Ang susunod na programa ay rated PG. Ito ay nangangailangan ng patnubay at gabay ng magulang para sa mga batang manonood.
Magandang hapon mga kachika! Panibagong araw, panibagong chikahan na naman ang inyong masusubaybayan ngayong araw na ito.
Tama ka dyan, partner. And kahit medyo matagal na at nakalipas na nitong October 5, gusto kong batiin muna natin ang ating mga kaguruan ng Happy World Teachers Day. Sabay-sabay tayong lahat.
Happy World Teachers Day!
Dahil kakatapos lang ng buwan ng mga guro, partner, we just have the perfect guests for today. Sila ang mga kilalang guro sa iba't ibang panig ng bansa.
Yes! At hindi lang yon, dahil today bibigyan nila tayo ng mga lessons and informations kung saan pwede tayong matuto para naman hindi puro chika ang pinag-uusapan natin dito. Gusto niyo yon?
Gusto ko yan, kaya wag na natin patagalin pa. He studied BS Chemical Engineering in Batangas State University and has 10 years of teaching experience in both Harvard University and Batangas State University. Please welcome Sir Juan Miguel Lopez.
Next, he studied elementary and high school at UST, and he took Bachelor of Science in Chemical Engineering in Harvard. And also, he took his postgraduate degree in Sustainable Chemical Engineering at Newcastle University and got an Industry Leadership Award year 2017. So let's give a round of applause for Sir David Romasanta. Medyo busy si Sir recently because of his TikTok videos, and thankful kami dahil naka-attend siya today.
Siyempre, last but not the least, yet again a BS Chemical Engineering graduate from Batangas State University and has 5-year teaching experience in De La Salle University, Miss Christine Naling.
Good afternoon po, ma'am and sir. Siyempre, bago po tayo mag-start at officially tanungin ang ating mga guro, hindi naman po kami magpapatalo ni partner. Kami po ang magsa-start ng ating discussion for today. Something about the chemistry of engineering materials. So we are going to tackle the basic concepts of crystal structures. Actually, ito pong episode natin for today ay intentionally ginawa natin for all the students or anyone na gusto po pong matuto academically, especially in science subject. Dahil balita po namin ang ating mga guro na guest po natin today ay mga science teacher. So, let's start. Let us discuss the learning objectives for our today's episode. Number 1 is we need to describe the basic structural unit or the building block of the crystal structure. Next is we need to determine to compute the density of a solid given its unit cell. Third is we need to classify the 4 types of crystals. And last is we need to describe the characteristics of amorphous solids. Let us define crystal. When we say crystal, it consists of matter that is formed from an ordered arrangement of atoms, molecules, or ions. And crystal structures have 2 categories of solids. First is the crystalline solid and second is the amorphous solids. So when we say crystalline solid, it has a rigid and long-range order and its atoms, molecules, or ions occupy specific positions. So let's make it simple. When we say crystalline solid, it has a recognizable structures, a well-defined angle, and a definite shape. So yung meaning dito na its atoms, molecules, or ions occupy specific positions, it means na masasabi natin na ang isang solid structure ay crystalline solid kapag meron itong proper or ordered arrangements. And ang example nito ay ice, salt, and diamond. While amorphous solids means absence of a well-defined arrangement and long-range molecular order can be observed. So when we say amorphous solids, these are the solid structures in which the particles are not arranged in any specific order. So, ang meaning nito ay ito ay naglalak the overall order of a crystal lattice. So, ang example nito ay glass, gels, rubber, plastic, and nanostructured materials. So, yung sinasabi ditong lattice or the crystal lattice, ang meaning nito ay a three-dimensional array of point coinciding with atom positions or sphere centers. So, it is used, itong lattice ay ginagamit in the context of crystal structures. Is the unit cell. When we say unit cell, it means the basic structural repeating unit of a crystalline solid. So, we are talking about the unit cell of a crystalline solid. So, di ba pag sinabi nating crystalline solid, ito yung merong proper or well-defined arrangement. And atoms or ions of a crystalline structures are thought of as being solid spheres, having a well-defined diameters. And atomic hard sphere model, this is the spheres representing nearest neighbor atoms touch one another. So, the atomic hard sphere model, ito ay ginagamit to show, to represent a crystalline structures. So, sa letter A, makikita nyo, this represents a unit cell. This is the unit cell of a crystalline solid. Then, sa B naman, makikita nyo, this is the extension of unit cell in 3 dimensions. And yung mga black spheres na nakikita nyo dyan, it denote either atoms or molecules. Okay, next, we are going to discuss the table 1, which contains the 7 types of unit cells. So, the angle alpha is defined by edges B and C. And angle beta is by edges A and C. And the angle gamma is by edges A and B according to Chang and Goldsby of 2017. So, in the first column is the unit cells, the second column is the figure, and the third column is the dimensions and angle. First is the simple cubic. So, let's look at the figure in the second column, and in the dimensions and angle of simple cubic, it shows that side A is equal to B and B is equal to C. So, all the dimensions are equal. And in the angle alpha is equal to angle beta, and angle beta is equal to angle gamma, and angle gamma is equal to 90 degrees. So, this simply shows that all the angles are equal and it is equal to 90 degrees. Next is the tetragonal. A is equal to B and B is not equals to C. Angle alpha is equal to beta and angle beta is equal to gamma and angle gamma is equal to 90 degrees. So this also simply shows that all the angles are equal and they are equal to 90 degrees. Third is the orthorhombic. A is not equals to B and B is not equals to C. So this simply shows that all the dimensions are not equal to each other. And angle alpha is equal to angle beta and angle beta is equals to angle gamma and angle gamma is equals to 90 degrees. So like the first two types of unit cells, all the angles are equal to each other and they are equal to 90 degrees. Fourth is the rhombohedral. A is equal to B and B is equals to C. So all the dimensions here are equal. And angle alpha is equal to angle beta and angle beta is equal to angle gamma, but angle gamma is not equals to 90 degrees. So this shows that the angles are not equal to 90 degrees. Fifth is the monoclinic. A is not equals to B and B is not equals to C. So all the dimensions in monoclinic are not equal to each other. Angle gamma is not equals to angle alpha and angle alpha is equal to angle beta and angle beta is equals to 90 degrees. Next is the triclinic. A is not equals to B and B is not equals to C. So like the monoclinic, all the dimensions are not equal to each other. Then angle alpha is not equal to angle beta, and angle beta is not equals to angle gamma, and angle gamma is not equals to 90 degrees. So this shows that all the angles are not equal to each other and they are not equal to 90 degrees. Last is the hexagonal. A is equal to B and B is not equals to C. Angle alpha is not equals to angle beta, and angle beta is equals to 90 degrees, while the angle gamma is equals to 90 degrees. So these are the 7 types of unit cells we need to remember. Their figures, dimensions, and angles. Again, the 7 types of unit cells. First is the simple cubic, second is the tetragonal, third is the orthorhombic, fourth is the rhombohedral, fifth is the monoclinic, sixth is the triclinic, and last is the hexagonal. And sir, do you want to add some additional informations?
Nakakatuwa naman ka, Chika, at meron kang basic knowledge about basic concept of crystal. Kaya, ang share ko na lang siguro ay tungkol sa crystal structure. You know, there are types of crystal structure. One is the face-centered cubic crystal structure, and other one is the body-centered cubic crystal structure. The FCC, or the face-centered cubic, is a crystal structure with atoms located at each of the corners and the centers of all cube faces. Para mas maintindihan po natin, take a look at the representation of the FCC, or the face-centered cubic. The face-centered cubic has a particle or atom in each corner and in each side. Yung blue po ay ang particle or atom sa corner, at yung yellow naman po ay yung atom sa each face. As you can see, yung mga particle na nasa corner don't touch in each other. Hindi po sila nagtatama. So, the actual unit cell consists of portions of the particles in the corner and in the faces. Kaya kapag po in-slice natin siya, ganito po yung mangyayari. Yan, as you can see. And kapag kinambay natin yung mga portions of atoms sa corner and portions of atoms in the faces, you can see na ang total nito ay 4 particles per unit cell. Comes from the portion of the side, and the 3 comes from the portion of the particles in the face. Sunod naman po is the body-centered cubic, or BCC. It is another common metallic crystal structure that also has a cubic unit cell with atoms located at 8 corners and a single atom at the center of the cube. As you can see in the representation, yun po, makita po natin dyan, yung body-centered cubic has a particle or atom in each corner at isa sa center. Kaya makikita po natin yung pink and blue circles. As you can see, the particles sa corner ay hindi din po siya lumalapat sa particles sa corner. Yung mga particles po sa corner or atoms. Pero, yung mga corner po, nakadikit po siya sa atom na nasa corner. Nasa center. Sorry. The actual unit cell of a BCC consists of portions of particles in corner and the whole particle in the center. Kaya po, pag kinumbine po natin siya, yung portions po, makakabuo po tayo ng isang particle. Kaya po, ang body-centered cubic ay may 2 particles per unit cell. Yung pong 1 particle comes from the corners, and yung isa po ay yung sa center. Kapag tinitingnan po natin yung FCC na magkasasama, ay ito po yung representation. Ito po yung mangyayari. As you can see, meron po tayong portions ng particles sa corners as well as the face. Kaya nga po sinabi ko kanina, kapag tinignan naman po natin yung BCC ng mas madami, ito po yung kalalabasan. Yung orange particle serves as the particle po sa corner, and yung green one is the circles. Or circles serves as the atom or particles sa center. Kapag nag-cut po tayo ng portions sa stacking ng particles, makikita po natin ang body-centered cubic crystal structure. Yung FCC crystal structure nga po, ay mas nag-occupy po siya ng space. Mas madami po siya na-occupy na spaces kaysa sa BCC crystal structure or body-centered crystal structure. There are two important characteristics of crystal structure. The first one is the coordination number, wherein in each atom has the same number of nearest neighbor or touching atoms. And the second one is the atomic packing factor or APF, which is the sum of the sphere volumes of all atoms within a unit cell divided by a unit cell volume. So, I think hanggang dito lang muna ang sasabihin ko sa inyo, ang i-share ko sa inyo. Hayaan natin marinig natin ang boses ni Sir David. Kasi sa mga TikTok niya, puro sayo lang yung nakikita ko eh. Hindi ko naman nakikita yung mukha, kaya hayaan naman natin siya magsalita. Sige, Sir David, it's your turn.
Huwag na nating pag-usapan yan kachika Sir JM. Ang mabuti pa, proceed na tayo sa lesson natin for today. So as continuation of what Sir JM discussed, let's move on to the final common metallic crystal structure. And this is the hexagonal closed pack crystal structure. So from the word itself, hexagonal, the top and bottom faces of the unit cell consist of 6 atoms that form regular hexagons and surround a single atom in the center. So between the top and bottom planes, there's another plane that provides the 3 additional atoms to the unit cell. And the atoms in this midplane have as nearest neighbors atoms in both of the adjacent 2 planes. So para mas maunawaan natin ang itsura ng hexagonal closed pack crystal, tingnan natin itong illustration. So kung makikita nyo, sa top and bottom plane, meron siyang a total of 7 atoms. Kasi sabi ko nga kanina, meron pang isa sa gitna nung hexagonal na shape. And sa midplane naman, meron pa ulit siyang 3 atoms. So to compute the number of atoms per unit cell for HCP crystal structure, this is the formula. N is equal to N sub I plus N sub F over 2 plus N sub C over 6. So, yung N sub I, siya yung number of interior atoms. Yung N sub F naman, siya yung number of face center atoms. And N sub C, siya yung number of corner atoms. So, 1/6 of each corner atoms is designated to a unit cell instead of 8 as with the cubic structure. This is because HCP has 6 corner atoms in each of the top and bottom faces for a total of 12 corner atoms, and 2 face center atoms, 1 from each of the top and bottom faces, and 3 midplane interior atoms. So using the given equation, we can find the number of atoms assigned to each unit cell. So N is equal to 3 interior atoms plus N sub F. So there are a total of 2 face center atoms over 2, and N sub C, there are a total of 12 corner atoms over 6. So if we solve this, we will have a total of 6. So there are 6 atoms assigned to each unit cell. So let's have another look at the hexagonal closed pack crystal structure. So in figure 5, in A, it is a reduced sphere unit cell, and A and C represent the short and long edge lengths respectively. And dito naman sa B, it is an aggregate of many atoms. So parang siya yung madaming hexagonal closed pack crystal structure na pinagdikit-dikit. It's according to Callister and Retwist in year 2014. So now, let's move on to the density computations. So a theoretical density can be computed with the knowledge of the crystal structure of a metallic solid through the relationship. So this is the formula. P is equal to N times A over V sub C times N sub A rather, whereas N is equal to the number of atoms associated with each unit cell, A is equal to the atomic weight, and V sub C is the volume of the unit cell, and N sub A is the Avogadro's number, the 6.022 times 10 raised to 23 atoms per mole. So now let's move on to the X-ray diffraction by crystals. So X-ray diffraction refers to the scattering of X-rays by the units of a crystalline solid. So yung pattern na napoproduce by diffraction or scattering ang ginagamit para ma-visualize natin or malaman natin yung arrangement ng particles in the solid lattice. So meron tayong tinatawag na wave interference. So ang wave interference ay ito yung nangyayari kapag ang dalawang wave ay nag-meet sa isang medium. And since X-rays are one form of electromagnetic waves, we would expect that these waves would exhibit such behavior under relevant conditions. So in 1912, Max von Loo, a German physicist, recommended that since the wavelength of X-rays is comparable in magnitude to the distances between the lattice points in a crystal, then the lattice should be able to diffract X-rays. So dahil yung wavelength ng X-rays ay maghalintulad dun sa distances between the lattice points, na-recommend ni Max von Loo na pwedeng mag-diffract ng X-rays ang mga crystals. So, interference in the waves associated with X-rays produced an X-ray diffraction pattern. So, yun. And, now, tingnan natin naman yung two types ng wave interference. Okay, so there are two kinds of wave interference. The first is the constructive interference, and the second is the destructive interference. So, para mas malaman natin kung anong pinagkaiba ng dalawang ito, let's look at this illustration. So, kung makikita natin, itong constructive interference, dun sa result ng wave 1 and wave 2, kapag pinagsama, nagkaroon ng bigger wave. Unlike dito sa destructive, na nagkaroon lang ng flat line. So, it is because sa constructive, kung mapapansin natin, yung wave 1 and wave 2, identical sila. Parehas yung crest, yung trough, and yung wavelength ay naka-align ng maayos. So, kapag nag-combine sila, nag-meet yung dalawang wave and nag-combine, magkakaroon ng mas malaking wave kaysa dun sa original. And like dito sa destructive, from the word itself nga, the destruction, magkaiba yung dalawang wave na mag-meet. So, salungat yung crest nung isa dun sa crest nung isang wave. So, in result, naghihilaan yung crest and trough nung dalawang wave and nagre-result na lang sa flat line. So, yun yung pinagkaiba ng constructive and destructive interference. So, let's have a look on a typical X-ray diffraction setup. So, as you can see in this illustration, we have the X-ray tube, the X-ray beam, the crystal, the shield, and the photographic plate. So, a beam of X-rays is directed at a mounted crystal. Then the atoms in the crystal absorb some of the incoming radiation and then re-emit it. Thus, the process is called scattering of X-rays. So, kung mapapansin nyo rin, din sa illustration, the shield prevents the strong undiffracted X-rays from damaging the photographic plate. Kaya naman dun sa result, makikita nyo na parang may letter L na shadow na puti. It is yung shadow nung holder and nung shield. So, the X-ray diffraction technique gives the most accurate method for determining bond lengths and bond angles in molecule in the solid state. Chemists can construct an electron density contour map from diffraction patterns because X-rays are scattered by electrons, but it is with the use of a complex mathematical procedure. An electron density contour map basically tells us the relative electron densities at various locations in a molecule. The densities reach a maximum near the center of each atom, and in this manner, we can determine the positions of the nuclei and thus the molecular geometric parameters. So, ito lamang ang aking may babagi sa inyong lahat at sana ay may natutunan kayo sa akin.
Siyempre naman po, sir, marami po kaming natutunan and huwag po kayong mag-alala dahil matagal po talaga kaming makalimot.
Nako, tamang-tama ka dyan, partner. Pero, bago tayo magpatuloy, I think we need break time kasi feeling ko kailangan na magpahinga ng mga brain cells natin for a while.
Ay, gusto ko yun. Kaya huwag kayong aalis. Stay put lang kayo dyan. Babalik kami dito sa Jen Cameron.
Anong tinitingnan mo? Ito bang voice combo sandwich na may kakaibang sarap dahil sa patong-patong na crispy wafers, over sa lutong na crackers, at yummy cream filling. Ito ba? Ito ba ang gusto mo? Hindi kita bibigyan nito. Kahit gaano ka pa kaganda.
Meron din ako niyan, no? Zipper mo bukas.
Voice Combo Sandwich. Ibang sarap pag may voice.
Nagbabalik kami dito sa Jen Cameron. Kanina, nag-share si partner ng mga nalalaman or natatandaan niya about sa basic concepts of crystals. Siyempre, dahil chikadora din ako, hindi ako papayag na wala akong share or machichika sa inyo. So, i-share ko yung mga natutunan ko or mga natatandaan ko nung college sa chemistry. So, di ba may nabanggit tayo na crystals? Meron tong mga properties and structures na malalaman lang natin if we consider the forces na nag-hold together ng particles. Yung mga forces na yon, merong classification which is ionic, covalent, metallic, and molecular. Di ba magkaklase tayo partner sa chemistry no college? So, if you don't mind, maaari ka bang mag-share pa? Or may natatandaan ka pa ba dun sa isa sa mga nabanggit ko?
Oo naman, no, may naaalala pa ako. Pero isa na nga lang. And hayaan nyo na i-share ko pa rin yun sa inyo kahit isa na lang yung natatandaan ko. From what I remember, ionic crystals are crystals that consist of ions that were bounded together by their electrostatic attraction. So let's search for some additional informations. I found out that ionic crystals have high melting points. And the stability of ionic crystals is measured by their lattice energy. So the higher the lattice energy, the more stable the compound. Also, if the ions are fixed in positions, these solids do not conduct electricity. And the ions are free to move when in molten state or dissolved in water. Thereby, the resulting liquid is conducting electricity. But there are two important characteristics of ionic crystals. First, they are composed of charged species. Second is anions and cations are generally quite different in size. And there are reminders in solving for radius of ionic crystals. First, the radii of ions must be known because it is helpful in understanding structure and the stability of the compounds. Next is, it is hard to measure the radius of an individual ion, but sometimes it is possible to come up with an estimation. And that is ionic crystals. And hindi ko na masyadong naalala yung ibang types of crystals, pero tanongin natin si Ma'am. Ma'am, baka meron po kayong gustong idagdag dun sa sinabi ko for our viewers for today?
Siyempre naman. Actually, tama kasi sinabi mo about ionic crystal. Pero, may nakalimutan kang tatlo. Kaya, i-discuss natin yung mga nakalimutan mo. Malay mo, may natatandaan ka pa, di mo lang malikap ng buo. So, pangalawa, sa type of crystals ay ang covalent crystal. These are crystals that are exist when atoms are held together in an extensive three-dimensional network, all together by covalent bonds. Ito yung mga solid na kung saan ang lattice point ay nasa mga atoms na covalently bonded sa iba pang atoms na malapit sa lattice point. Example of covalent crystal are the two allotropes of carbon, the diamond and the graphite. Diamond is one of the hardest naturally occurring substance known. The unusual hardness and very high melting point of diamond are attributed with the strong covalent bonds that exist in 3 dimensions. Madalas natin siyang makita sa mga jewelries na sinusuot natin. While the graphite is considered as a good conductor of electricity in direction along the planes of carbon atoms. Ang graphite ay magandang conductor ng electricity dahil ang electrons niya ay nakakagalaw in an extensive delocalized molecular orbital. Graphite is effective as lubricant and also used in pencil kasi diba slippery siya, and also used in ribbon made for computer printers and typewriters. Another example is the quartz. Ang silicon atom ng quartz ay may pagkakatugma ng arrangement sa carbon in diamond. But quartz may presence ng oxygen atom between each pair of silicon atoms. Madalas gamitin ang quartz sa glass making like chandelier. Next type of crystal is the molecular crystal. Its lattice point are occupied by molecules which has a van der Waals forces and hydrogen bonding. Van der Waals forces is the attraction of intermolecular forces between molecules. Ang molecules ng molecular crystals are packed together as closely as their size and shape allow. The intermolecular hydrogen bonding is mainly responsible for maintaining the 3-dimensional lattice of ice. Iodine, tetraphosphorus, and octasulfur are other examples of molecular crystal. The last but not the least type of crystal ay ang metallic crystal. It has the simplest structure because every lattice in the crystals are occupied by an atom of the same metal. Ang bonding ng electrons in metal are delocalized over the entire crystal, which is actually different from other types of crystal. Yan yung 4 na types of crystals. Sana ay may natutunan kayo sa mga sinabi ko.
Yes po ma'am, marami po kaming natutunan sa inyo. At mukhang busog na busog din ang ating mga viewers sa dami ng kanilang pwedeng matutunan ngayong araw sa mga information na binabanggit ninyong mga guro.
And bago tayo matapos for today's episode, meron pang last na i-discuss natin for today, and yon ay magagaling sa aking partner.
Like mentioned before, meron tayong tinatawag na amorphous solids, and these solids solidifies fast that the atoms have no time to arrange or align themselves. So, yung position ng mga atoms na yun, it's different from regular crystalline solids. These solids lack a 3-dimensional arrangement of atoms, and it lacks a ordered internal structure. Wala din siya nung tinatawag na regular external structure. Doon naman sa intermolecular forces ng amorphous solids, mas mahina yung intermolecular forces niya kumpara sa nandun sa crystalline solids. Amorphous solids actually have 2 characteristic properties. One is that when it's broken, it actually produces irregular fragments, often with curved surfaces. And number 2 is that they have poorly defined patterns when exposed to X-rays because their components is not arranged in a regular way. Amorphous solids actually have no distinct melting points kasi nagme-melt siya sa different temperatures. And some examples of these are rubbers, plastics, gels, and more importantly, glasses. Glasses is actually commonly referred to an optically transparent fusion of inorganic materials such as boron oxide, silicon dioxide, some transition metals that has cooled down to a rigid state. Glasses, its chief component is silicon dioxide. And since mas nagbe-behave siya as a liquid, it is commonly referred as supercooled liquid rather than a solid. Tapos, according sa X-ray diffraction studies, glasses actually lacks a long-range periodic order. Glasses actually have 3 types: pure quartz glass, Pyrex, and soda lime glass. Pure quartz glass is 100% silicon dioxide and it has low thermal expansion. It is transparent to wide range of wavelengths and it is used commonly in optical research. The second one is Pyrex glass, which is composed of 60 to 80% silicon dioxide, 10 to 25% of boron trioxide, and a bit of aluminum oxide. It also has a low thermal expansion. It is transparent to visible and infrared, but not to UV radiation. And kung mahilig ka magluto, you probably heard of this Pyrex kasi it is commonly used in cooking and it in laboratory actually. The third one is the soda lime glass, 75% silicon dioxide, 15% sodium oxide, and 10% calcium oxide. Unlike pure quartz and Pyrex glass, it is sensitive to chemicals and heat shocks or thermal shocks. It transmits visible lights but absorbs UV radiation, and it is used mainly in windows and bottles. Glasses, as we can observe, have different colors, and these colors depends on the presence of metal ions as oxides. Sa green glasses, it has iron oxide and copper oxide. Kapag yellow, it has uranium oxide. Kapag blue, cobalt and copper oxide. And lastly, kapag red, merong small particles of gold and copper. All those na nabanggit ko na metal ions are mostly derived from transition metals. Yun lang yung sa amorphous solids. Sana ay madami kayong natutunan at magamit nyo ito sa inyong pag-aaral.
Yes, and of course, thank you po, Ma'am and Sir, sa pagsama sa amin sa hapong ito and sa ating mga viewers na talaga namang sinuportahan tayo at sinamahan tayo ngayong araw. And we really hope na kung meron po tayong mga episode na katulad ng ganito ay samahan niyo pong muli kami.
See you again tomorrow mga kachika dito sa Gen Cameroon.